This is a continuation of the discussion of Test 3. I'm picking up at question number 18, and the topic is quadratic functions. It appears that they're going to focus on one particular concept or part related to quadratic functions, and that is the ability to find the vertex. Now, finding the vertex of a quadratic, which remember visually, a quadratic function is a U-shape or a parabola, and it can either be turned up or it could be turned down. And the application for this in a lot of different things in business and so forth is the quadratic. The vertex is the point where it's changing direction, where it kind of bottoms out or tops out. And that particular point is either the minimum value of the curve or the maximum value. And oftentimes, like in business, we want to be able to maximize our profit, or we want to minimize our cost. And if you have a quadratic function that represents your cost and or your profit, then you can do that by simply finding the vertex of that. Now, there's lots of ways. There's a couple of ways to do it. The easiest way is to use a formula, and this formula is actually derived from the quadratic formula, but in simple forms, here it is. To find the x coordinate of the vertex, which is often referred to as h, you do the opposite of b over 2a. Then to find the y coordinate of the vertex, which is often referred to as k, you actually substitute the value you found for the x or the h back into the problem. And that gives you the ordered pair that corresponds to the vertex, which is your low point or your high point of your parabola. Now, again, you may think, well, okay, where do a, b, and c come from? Remember that a quadratic is in the form a x squared plus bx plus c. So the a is the number in front of the squared term every time, all the time. B is the number in front of the x term every time, all the time. And c is the constant, assuming it's in that standard or general quadratic equation form. So in this equation that I have here, a is 3, b is -8, and c is 5. So if I substitute what I know into the formula, the x coordinate would be the opposite of b over 2a. So I'm going to have the opposite of -8 over 2 times 3, which gives me +8 over 6, which simplifies to 4/3. To find the y coordinate of the vertex, I then have to take 4/3, which is going to be kind of messy, okay, to plug back into the equation to get my y coordinate. So if I do that, if I substitute 4/3 back into the original function, I have 3 times 4/3 squared minus 8 times 4/3 plus 5. So I have 3 times 16 over 9 minus 24, oh, excuse me, not 24, 32, so 32 over 3 plus 5. 3 times 16 ninths, 3 goes into 9 3 times. So I have 16/3 minus 32/3 plus, and I'm going to change 5 into thirds, it would be 15/3. So working from left to right, 16 minus 32 would be -16/3 plus 15/3, which is -1/3. So my vertex written as an ordered pair would be the vertex would be, the vertex would be the ordered pair 4/3, comma, -1/3 for that particular function. Now, there are other points that you want to look for in a quadratic function. They don't really address them here, but I want to mention them because you might be asked to do that later. I don't think you're asked to do that on the test, but you may be asked to on the final. Also, with quadratics, as with any function, you can find what's called the y-intercept. To find the y-intercept for any function, we let x equals 0 and we solve for y. So in this scenario, if I let x equals 0 and solve for y, I have 3 times 0 squared minus 8 times 0, and what was my last term? Plus 5. Plus 5. So we would have 3 times 0 minus 0 plus 5. That's 0 minus 0 plus 5, which ultimately is 5. So the y-intercept where we cross the y-axis would have the ordered pair 5, 0. The other values that you often want to find, and they're going to address this a little bit later with polynomials, the other value you want to find related to a quadratic, or really any function, are the x-intercepts. But the x-intercepts are actually also called the zeros. They could be called factors, or they can be called solutions. So those words are synonymous in algebra, and they all mean the same thing. To find the x-intercept, we let y, or our f of x, equals 0, and we solve for x. Now, to solve for x, you have a couple of options. We have our equation 3x squared minus 8x plus 5. And then we'd have to try to see, does this thing possibly factor? There's two methods for solving quadratics. And looks like my 3 disappeared here. And our two options when solving quadratics, we can either factor or use the quadratic formula. Now, me personally, I just assume factor if the problem factors. If it doesn't, then I'm going to resort to quadratic formula. A lot of students will actually just go straight to factoring or to the quadratic formula because they're not fond of or they don't want to try to do factoring. So it's kind of up to you which method you use. I believe that this one will factor. We would have 3x times x, we would have 1 and 5, and that would really be 3 plus 5, and those both will add to 8. So we have 3x minus 5 could have been 0, or x minus 1 could have been 0. And I want to solve each of those respectively for x. So I would add 5, add 5. So I have 3x equals 5, divide by 3, divide by 3. So x is 5/3. Solving the other one, I would simply add 1 to either side. So x equals 1. So written as ordered pairs, the zeros or the x-intercepts are 1, 0, and 5/3. 0. It's a little bit more than maybe you're expected, but again, I wanted to make sure you had that understanding because at some point you may be asked to find the zeros or the y-intercept of a quadratic or of any function for that matter.